Hey there, welcome back. So, yeah, let's get started. So, in yesterday's video, we talked about we read it through MIT's attached PDF, like the lecture slides. Yeah, this is what we covered. Uh, I did say I will be covering like some of the. We didn't have a time yesterday, so today I'll be like completing some of the stuff that I said. I will explain in what you can say like, in depth. So what did I skip? I think I did explain the stack storage one, and also yeah, this is okay. Yeah, I did explain this to external fragmentation. Yeah. So yeah, I guess I didn't explain like what is disk thrashing. So what and also TLB. So what's happening is that let's explain TLB first because like I have a good memory about it. I don't quite remember disk thrashing because watching which can increase the size of the vegetable. Okay, yeah, fine. Okay, so TLB is like a cache for the page table. So what happens is that we have page tables, which maps virtual memory to physical memory, but TLB caches those page tables. So it's like easier to uh, convert the addresses. So yeah, that's it. So if so, this is what is happening here over here. So let's say our data is split into two different what you can say two different pages. Not this is not a good representation, but okay. Let's say our data is split into two different pages instead of one. So we have to cache both of them. On the other side, if it was just one, then we will have to only cache like the one, and that is better, you know. So yeah, can be a bit of problem in this case because pointer and these many pointers they happen to be like in multiple different page tables, so that's the problem in this thing. But yeah, okay. So if the page goes empty, I guess this is fine. If it's a different thing, if it's in different pages, you can see that probability of two random accesses. Uh, this is like 90% probability again, and here only 1%. This is better than this, whatever this is. Yeah, okay. So I guess that was it. We did talk about this structure. So we'll be implementing bin free list. Uh, yeah, I guess we do have to look into. Okay, let's talk about like today's video. So today we'll be covering first I have to fix like the assembly error when we try to compile the attached code. So I'll try to debug it. Next, we'll be looking into how to implement bin free list, and if possible, I think we'll start coding in this video itself. So I guess that's it. Also, I don't have much experience, you can say, with C because I have been you like I do get some of the things. It's I have experience with C++. I know it's a superset, but you know it's those things okay, I haven't used much of pointers in C++, and I'm like jumping into a C project that will most likely be using like a lot of pointers. So yeah, that part will be a bit challenging, but yeah, that's cool. And I guess I don't have anything to say. I did read about like pointers, uh, there's a book called Beach Guide in C. It's a really good book. I'll show you. Where is it? Liverpool. Why did I do that? Okay. So Beach Guide to C programming. So yeah, this is the book. You can go on Beach's website and then choose the PDF, whatever. So yeah, if you can, please support this too. I'll be supporting, but I don't have my own money yet. I am not employed, so but I will be supporting. So thank you, Beach. I also while making another project, I did read about the network programming PDF. I did it entirely. It's a really like I from top to bottom. I completed the entire book. It's so like Beach is a really hilarious guy. I'm not sure if it's his name or her name, but they are like uh, the it has the book has like a lot of puns. So yeah, just a minute. Just give me a minute. I'll be going out of frame. Just a minute. Back again. So so what was I talking about? Yeah, Beach's guide. So I've read about like Beach's guide in network programming, and it's like uh, they are pretty hilarious. Like a lot of puns in there, and like a really great read. So yeah, I would highly recommend that. If you can support, do support them. I'll be supporting them too. But yeah, after I'm employed, you know. Okay, so let's get back. What were we talking about? Yeah, this one. So we did talk about like how this works. I guess my previous explanation was like a really bad. Yeah, that's the word. Uh, but I think it's as I've said, I would like highly recommend you to like go and watch the 1 hour video. It's like lecture 12 or 13 or 11 maybe. It's a storage allocation, and yeah, that's it. So let's get on to like our first problem, which is why isn't it compiling? So yeah, as you can see, the error is like unknown register name edx in assembly. So why are we getting this error? I looked it up. I guess I looked it up in the like previous video itself, uh, and I found out like edx is like definitely edx. We have seen eax, edx. These are like x86 registers, and this is a Mac with ARM architecture, so it doesn't have. Uh, you can say those registers. It has like something like R0 or R1. I don't know, but I'll figure it out. So let's first check how many. Oh, not this. ASM. Oh, why? Okay. Yeah, RG. Let's first. What? Yeah. Let's try to find like how many assembly codes are there. Okay, that's just one. RGASM. It's inside clock.c. Okay, that's it. So if we go into clock.c assembly, so this is the only code that we have. So okay, wait. Yeah. So this is the only assembly code in here. So RDTSC, not sure what that means. Read cycle counter. Okay, yeah, yeah, whatever. Move L, move 0 into EDX register, move 1 into AEX, and it's equal to R uh, high high value, like the high I guess is a pointer. I don't think we'll find that over here. High and low, where are they coming from? Access counter. Yeah, this is it. Yeah. Okay, they are just values. The two outputs, no input, EDX, AEX. Move EX value into EDX. Yeah, okay. I think I will get like a better one. Like not better one. I'll like get something compatible with this Mac ARM architecture. So let's look into it. LibreWolf. I've recently started like as you can see, like this is LibreWolf. This is like open source and it's a Firefox based browser. I don't really like Firefox based like browsers. You can see I don't think that. Okay, so Chrome has better developer tools, but also like the extension thing. I tried to create my own extension. I found out we have to like get it signed. Even the when you want to make it like, okay, you can use temporary, but you have to like load them up every single time. Uh, Instead, like to make it permanent and stuff, you have to like make a Firefox account and get it signed, and then you can use your own plugin. That's I didn't like that idea. So yeah, let's get back to the video. Okay, so I was searching for assembly code for. Let's just confirm, like, does architecture have EDX register? No clankers, come on. I want something simple. I think I'll go for like Stack Overflow. These are like big documentations. I am not that into it. Interchangeable other data registers, EX, VX. What are they talking about? No, this is a completely different question. Stack Overflow machine templating. So let's do one thing first. Let's try to copy this. Error, unknown register name, EX in assembly. Yeah. Architecture. So yeah, what do we find? Nothing. Come on. What? Okay. I think it isn't like finding like the exact thing. Let's remove this. Let's remove all the fancy special characters, EDX in assembly in our architecture. I guess this is okay. Yeah. R3 in assembly. Wait, that's what I was looking. What is R3 registered in? Just R3 register. In assembly. I should have talked to in assembly. Assembly. So in assembly, what is the line R3 plus do? Okay, I have lines in assembly. I will do effective address A. This line are R3 plus R2 plus signs. I think a lot of DSPs, but the RN typically means indirect using address and register N. I think this is a completely different thing. Yeah, let's look at this one. Stubborn coder. So the register on a CPU are very fast. Okay, I'll full screen it. Yeah, the registers on a CPU are very fast and very small internal memory that the CPU ideally uses it to do its calculations. The registers on a 64-bit CPU are 64 bits wide. In the 64-bit x86 architecture, there are 16 general purpose registers. They are named R0, R1, R2, R3, R15. The first 8 of these registers also have special names for historic reasons. They are in order RAX, RBX, RCX, whatever. We usually use these names in our code as they are much more readable. Technically, we can read and edit these 16 general purpose registers as we wish. However, 3 of them, RCX, RSP, RBP, have certain restrictions. Okay. Yeah, I think we will find what that means soon. Let's keep reading. So the RCX register is used implicitly as a cycle counter by the loop instruction. C stands for cycle. If you use the loop instruction and the RCX register simultaneously, things will go wrong. However, as long as you aren't using loop, then you're free to use RCX. The RSP register is used to point to the top of the stack in memory. SP stands for stack pointer. We only use RSP to access the stack. The RBB pointer is used to keep track of stack frames, and we only use it and we only ever use it when calling functions. PP stands for base pointer. Okay. So this is also there is also the RIP register, RIP, that holds the address in memory of the next instruction that will be executed. That holds the address in memory of the next instruction. Okay. Got it. The kernel jumps to a different instruction by editing this register. You can access the RIP register and edit its value if you wish, but it really isn't advisable. If you want to jump to a different instruction, you should always use the belt and jump commands. Yeah, got it. There is also a completely separate set of registers used entirely by the kernel that you cannot access. The most interesting of these is the flags register, which holds various flags that are set whenever the CPU performs a computation. For example, the zero flag, which indicates that whether the result of the last computation was zero. These are the registers that are checked. Wait, why is there a like flag to say like the last computation was zero? Is that like performance optimization or something? Okay, so these are the registers that we checked when we use a comparison instruction. There are various other registers that the kernel uses to keep track of things like the current position, level, or virtual memory. Okay. When using the 64-bit general purpose registers, we usually read and write 64-bit values. However, we can also read and write 32-bit, 16-bit, and 8-bit values. I write 64-bit. Okay, good. In my experience, this is mostly useful when we want to check the value of specific bytes. For example, when we are searching an ASCII string for a specific character. We can use the lower 32-bit, 16-bit, and 8-bit segments of registers by adding a special suffix to the standard register names. To access the lowest byte, we add B. To access the lower 2 bytes, we add W. To access the lower 4 bytes, we add okay. To access the lowest byte, we add B. To access the lower 2 bytes, we add W, and to access the lower 4 bytes, we add W again. W and W. So, for example, we access the lower 4 bytes of R3, we will write R3W. To access the lower byte of R14, we use R14B. Got it. Corresponding to legacy register names, RAX, RBX, they are similar legacy names for the lower portions of register, R0 to R7s. We access the bottom 4 bytes with AEX. So this is it. We access the bottom 4 bytes with AEX, EBX, ECX, EDX, ESP, the bottom 4 bytes. The bottom 2 bytes are AX, BX. Got it. Okay. So what do we do? So I got it. So I don't think it's wait, does assembly code differ for architecture to architecture? Right. assembly code in x86 versus ARM. Let's take a look. Key differences explained. I don't want to watch a video, just show me like the difference in the code. Okay, comparison for simple 4x for single procedure. So M128 R1, so they're still using the R0 and R1 convention. I don't think that is good representation. Okay, let's see this one. Yeah, that's what I wanted to take a look at. So as you can see, x86 has EAX and EBX or whatever. And can we change that up? Can we just simply like okay, wait. No, certificate down. Let's go to this. Let's go to, no, I don't want to walk. I don't want this. I want like yeah. Wait, there's no attach thing. There's nothing. Okay, so I got it. So like mapping of x86 registers to assembly registers. So okay, map onto EX. So you're getting my point, right? So let's say if I go into like clock.c and I modify this, since it wasn't able to like identify EDX. What if I write like R0? Well, there was the error. I think I should initialize Git first. So I think let's okay. So clock.c. Let's take a look at. Let's take a look like this, and how will we? Let's initialize the Git first. So first, I think the first thing that I want to do is like delete this. So let's say I have, wait, what are these? On desktop I have these files. Oh yeah, I got it. Yeah. So let's remove the rm-rf mit, this one. So we'll unzip it again. So yeah, wait, what is this? Okay, let's forget that thing, whatever. So cd mit. So let's move this onto like let's make a GitHub repository. Wait, should I be showing you guys my GitHub? Let me hide my screen for a bit. You can look at my face. So okay, GitHub. I think there's no point in like not showing my GitHub. But yeah. So new. What should we call our allocator? My malloc is like pretty boring. We can keep it. It's not that bad. So malloc. So I got it. So wait, let me show you. I'll just reveal it. So I think I'll call it. Yeah, that's a good name. Okay, public Visibility, don't add a readme, create repository. Got it. Got it. I'll clone it onto desktop itself. Yeah, got it. So move MIT my work to here itself into R. Is it done? Wait, why did I move those things? Wait, I messed up. So yeah, I messed up. So cd wait. Oh, I'm messing up stuff. Afterward, so we don't need this one. Should I show you what I'm doing? Wait, let me just ensure some stuff. Yeah, I guess this is fine. It's already done. Let me close that tab. Yeah. Okay. I guess this is it. 1 2 1 2. Yeah, that's great. So I have made, so this is a project name R Malak. What is the pun, you will be asking? So the pun over here is that if you go on YouTube and you look at like memory allocator low level learning, so as you can see, he has said like I wrote my own memory allocator in C, my, and the name is my alloc. So I kept it like R malloc. Oh, I shouldn't have, like, not R malloc. It should be R alloc. I'll fix it. Wait. I'll fix it. Just a minute. Look at my face. I just have to rename the project. I think my decision to like hide stuff was like good because I have like some private repositories, and there's no point in like showing private repositories to the world. Like, why are they private? They are private for a reason. So yeah, I'm not changing any of this stuff. Yeah, verifying. Done. So the project is successfully R alloc now. Wait, what? It didn't change anything. Where is the confirm button? Oh, I have to press the same button again. Okay. Got it. Okay. So rm -rf git clone boom. Got it. I can show you stuff. So yeah, I've successfully renamed. Sorry, that must be like pretty boring. Like you must be like I think you have already left the video, but it's fine. No problem. No problemo. So, uh, yeah, I've made like the name is ralloc now, and we'll just move the files from here. So move asset star, move star to desktop, and ralloc. Is it done? Yeah, is it done? That's done. So see there, ralloc, and is that there? Yup, they are over here. Let's go. I think I need to take a look at another thing, which is clean.py. Let's say m driver. Yeah, nothing over here. I looked it up. Like, what is clean.py? It's like a library that helps you make terminal applications and something. Yeah, okay. Exit. So our alloc is finally ready, and yeah, it has a git. I should like specify like this is like open source and something. I should add a license and something, right? There should be license. Yeah, I'll add it afterwards. Okay, so first of all, git status, nothing is git commit backman. My first commit is usually always backman, except like in professional environments. But yeah, let's go. Backman is a great guy. So yeah, let's go. Let's get working. So cd clock nvim clock.c. So this is what we are working on. What is rdtc? Let's look at this. Why are we full screen, bro? Yeah, I'll remove this one. rdtsc in assembly. What does rdtsc mean? The RDSC read timestamp counter instruction is used to determine how many CPU ticks took place since the processor was reset. Loads the current value of the processor timestamp counter into the EDX, AEX registers. It is commonly used as timing defense and a debugging technique. Okay. Get current timestamp saved it in 64-bit value. EDX first half, EAX second half. XOR ECX, set ECX to 0. Add ECX to AEX, save timestamp to ECX, got it. RDTSC, get another timestamp, compute elapsed type ticks. Okay, so it's like it's used to like get ticks. What is move L? What is move L in assembly? The difference between move and move L instruction. Yeah, that is a legit concern. Like, not concern, that is a legit doubt. What does that mean? So recently I read some books, I wrote some C code, discipline, GCC and bookism, and this move and move L. Okay, I don't understand the difference between move and move L instruction. Why the compiler generate move for some code and move L for other. I completely understand the meaning of the C code, but not the assembly that the compiler generated. Who can make some comments for it to understand? I will think a lot. The move instruction was generated because you put two I and j variables. Move will perform a move operation of 32 bits and integer size is 32 bits. A non-exhaustive list of move star exists, like move t for double word or move q for quad word, to allow to optimize your code to use a better expression to gain most time as possible. Maybe the -m intel objectum argument can help you have a better comprehension. The move instruction was generated because you put two int I and j move. Okay, wait, I didn't understand like anything. Wait, are you getting, like, is it visible? Yeah. Okay. I'll full screen it now. Yeah. Okay, so difference between, yeah, let's look up difference between move and move. I'll remove the previous stuff, like we know this stuff too. I'll keep this one, sorry. I'll keep this one to what is move, yeah, keep this one too and this one. Yeah, let's go. Yeah. Moving, we looked at this, move and it says move and move. Use of expression operates with the difference between move. Yeah. Finally there's like a Reddit post. Yeah, I would like to understand the difference between move and move. I know they both transfer data to a destination depending on the size of the both sources and the destination. But why would you use move in order to move 32-bit word instead of moving it to 32-bit register from move with move? There are lots of variants of the move instruction. If you are writing Intel syntax, you write move and the assembler works out which instruction you mean. Sorry for the disturbance. If it is ambiguous, there are ways of clarifying. If you're writing AT&T system, you use move-L and move-V. Okay, so it's just like we are explicitly saying that this is like integer operation. Is that it? Yeah, fine. So let's go. So first, what do I want? Assembly in ARM architecture. Let's look at that first. So getting started with ARM assembly language. What's the difference? Oh, I finally found it. Okay. Registers. Okay. Okie dokie. For example, we might want to do any of the following: increment register by 1 at x0, loading data into registers, x3. What is this? There are example functions, so we'll enable to run x86. Okay, let's look at this one. Wait, I haven't tried like what is the make file? So make file is using clang. What if I gcc? Now it's saying that its status is it updating? Yeah, okay. Make clean and then make file get status. What is C flags? Okay, that's fine. So let's go. This is a bit exhausting. We are already 39 minutes in and we haven't done anything. So yeah, let's go. And then clock.c RDTSC, it's to get like the current ticks, to get like the tick count. It's a tick counter. Move-L ADX to 0, AEX. Okay, ADX AEX. What if I just like, okay, let's say yeah, EDX. Where have they mentioned EDX? So it's not mentioned. Different registers for assembly in ARM versus x86. Differences is ARM assembly and x86 assembly. The main differences between main differences in types, new types. Okay. ARM is a RISC style architecture. Instructions have a regular size, 32 bits for standard ARMs, 32 bits for standard ARM, and 16 bits for thumb mode. Though thumb has some instructions that chew up 2 instruction slots. Yeah, that's not. It's like too deep for this stuff. Is like okay, too deep for me. Oh man. Yeah, to read and write the x86. Wait. Hold. Not watch it. Loading. Yeah, so it has EX. What if I say I want GCC? What if I say Arch? Is it ARM? Yeah. Got it. Wait, let's first understand like what it's doing. So ARM v7 Clang. Wait. So okay. Board.org. So 9, 8, 9, 9. Wait, what? There's too many stuff. So this one. Let's remove this one. This one too. This one too. This one. This one. Okay, that's fine. No. 7, 8, 6. Sorry, 6 and 7, 6 and 7, 6. It's the same stuff. Okay. So GCC. What were we using? x86 GCC was it this one? Yeah, okay. So let's do one thing. Let's say int y is equal to now. Okay. So we have this dword pointer. What that means I don't know. Ex, and that the same on 7th code. 16. Why is 6 and 7? Wait, what? Okay, why am I not able to access this? Wait, 5. Oh, okay. That's fine. Good. So 5, 6, 5, 6, 5, 6, 5, 6. Just return to the previous code. Okay, 5, 6, 5, 6. Okay, so LDR move. Wow, this is so confusing. Convert x86 assembly to ARM assembly online. This is my last option. Online assembler and disassembler. Okay, so what does this do? Let's organize this. So temp. Oh man, this is so confusing. Come on, I want a break. I can just use a LLM right now, but I don't want to because this is unofficially a no clanker challenge. Yeah, so I'm not going to. Let's figure it out. Let's just try replacing like R0 and R1 randomly. What do you say? What's the worst thing that can happen? I'm going to. Okay. This is. I am not sure what I'm doing, but okay. Right. EDX is R0. Wait, but we. EX was R0. Okay. So EX was R0. What is. Um. What is EDX? Is it R4? Wait. Uh, Man, I'm so done. R4. Wait, so E is 0, A is 0, B is 1, C is 2, and D is 3. Okay. I am so done. If this works, I'm going to be like really hyped up about myself. 1, 0, 3. Yep. Hi. Value does not match register size specified by the constraint and modified W assembly. Instruction mnemonic assembly. Unrecognized instruction mnemonic. Percentage B W1. Hmm. Let's try doing what um, the compiler is recommending. We read about this, right? Like something like the W keyword. Unrecognized instruction mnemonic RDTC instantiated into Clang. Go to C in Clang. The return cell assembly into C. How to assembly x86 code with Clang. Let's take a look at those things. I'll just remove this one, 7. Yeah. I remember back in the day, ASM, GCC, this. Okay, let's try this. Cog.c. Like there's no, I guess there's no use to write, to like add GCC and stuff because at the end of the day it's like it just converts to Clang itself, right? On Mac at least. Yeah, see? It's the same thing no matter what. So it must be so boring for you to watch this. Like you might be like screaming answers and all. Like you must be like knowing stuff, and I'm just here like okay. As your boot is getting some kind of error. PC error GCC clang. Hmm. not give up right now. If you're doing it purely for fun, not about 650 or 2 cents. Wait a minute. Oof, okay. So, and this is of no use. What does equal R mean? What is R and double percentage in GCC inline assembly language? Okay, so in main this assembly move L percentage 1 EX equal to R. Okay, got it. Equal to R. Got it. Yeah, okay. The person is asking the same thing. Okay, so this is GCC inline assembler, which is very powerful but difficult to understand. First of First off, the percentage character is a special character. It lets you define register and number placeholders. More on this later. Unfortunately, the percentage is also used as a part of the register name, such as EX. So in GCC inline assembler, you also have to use two percentage characters if you want to name a register. Okay, percentage 0, percentage 1, percentage 2 are placeholder input and output operands. These are defined in the list followed by the assembler string. In your example, %0 becomes a placeholder for y and %1 becomes a placeholder for 1. The compiler will make sure the variables will be in the registers for input operands before the assembly code gets executed, and it will make sure the output operand will get written to the variable specified in the output operand list. Now you should get an idea what ry is. It is an input operand that reserves a register for the variable y and assigns it a placeholder 1 because it is the second operand listed after the inline assembler string. There are lots of placeholder types. Okay. Got it. So how to get GCC in Mac M1? Instead of clang, I'll type in like red. There must be some person who GCC in Mac, C programming, installing GCC in Mac, no C programming. I'm a special guide abuser. Let's try this. So to install GCC, we do have reinstall GCC. I do want to watch this video. Use GCC on Mac instead of Clang. Okay, so cd GCCV, Clang version, cd Clang version. Here is the code we compiled, but on Linux with GCC it will raise a float conversion error. And okay, the -w float conversion option gives a warning if you convert a double. So it's saying like there should be no problem. Yeah. Yeah, the same thing. Come on. EX and ASM, and then oh, I was going to try that. Okay. The GCC from home view should be a symbolic link that resides in US local bin for Intel and Rosetta to install or OPT improve for Apple Silicon. Okay, with this build version of GCC, show up in the GCC client, you are done. The local will be installed, use the package. Put this inside the open solution which uses as well. And okay. Let's try that. We'll go for the path. Miniconda, Conda, Apple Security, Crypto, Silicon, CryptXT, CryptXT, CryptXT. This is our stuff, emulator, Ghosty, Go, VMware Fusion, Ability, Web Internal. I am too old for this. That's why I'm too young for this. Okay, let's try again. We are already like, oh my god, we are 1 hour in and we haven't done anything. My god. Okay, so we are having an error. So I'll make the GCC thing in. Okay. So log dot C R3 R0. So let's have a 27th line. Okay, it's on the 27th line. Okay, so we are having error over here. It's not recognizing this. So if we do wait. And then clock. Clock.c, and if we try to move this, so R3. Oh, I got it. So wait, this is supposed to be double percentage, right? Is that why the error was? No. And then clock.c, because like we read okay, so let's try the age old thing, R3 and R0. Yep, new errors, 2 Onyx and 9 errors. Oh man. Unrecognized instruction mnemonic. ARM64 LLVM unrecognized instruction mnemonic. Okay. I'm trying to use, finally something relatable. I'm trying to use ARM assembly in a C code. I am compiling using Arch64 Linux. Okay. And definitely we don't have any answers. Oh man, I'm so tired. If you want to build Arch64, it would help to use Arch64 instructions. Yeah, got it. When I look up ARM documentation, DUI, which is some reference guide. ARM assembly reference guide. So instruction set reference guide. This is what we had opened earlier. Okay. Wait, what? Hmm. What was this then? Where did the PDF go? So wait, what is this one? ARM assembly language. This is the same stuff. Wait, I'll desktop. Oh, I'm showing you all my personal stuff. Yeah, sure. Fine. Wait, I didn't download that. Yeah, let's go on desktop. Oh my, this is so dumb. Mac. Just save it, man. Yeah, come on. Okay, so we want registers, something related to registers, and continuous code. And hide this. Okay, don't hide that. So registers, did we find anything? Registers, okay. Loading data into registers, using debugger to investigate registers. How is it? I want to take a look at like how is it different from like yeah, sure. In fact, E64 assembly code, let's say each is from phase, each is can be used 64-bit registers, X0 to X30. What is the difference between R registers and EX? Difference between R0 and EX. Assembly language register electric references assembly. How is RX different from EX? Well, in the book the registers are EX. Whatever. Come on, explain. The registers starting with R as in RAX, RBX, etc. 64-bit registers introduced with the IMD64 extension to the existing 32-bit x86. Okay. Now that the 32-bit, these are 32-bit EX. Okay, registers like EX are 32-bit integers. Registers which exist both in original 32-bit x86 ISAs and 64-bit. Just the two of us. I should be like singing songs in between because that might be okay. Wait. So EX are like 32-bit, right? So assembly registers 32-bit registers. Assembly 30. ARM architecture 32-bit registers. Did write and registers part 2. Okay. Just the no, so don't say it. Hey, you! I was right about this. Yeah, the following table is just mentioned the ARM registers relate to those in interprocessors. Yeah. Hey, so I was correct. So, okay, so EX is R0, R1, R2, R3. I was correct about that. What? Can we use this common x86? Yeah, let's do it. So, clock.c. Just the two of us. R3, R0. clock.o error 1 assembly rdtsc. Value size does not match register size specified by the constraint and modifier ws operand pointer to I. This is supposed to be like 64 bit. What is it? Is the two of us? Who's the two of us? Unrecognized instruction harmonic rdtsc. Remove. What was I going to search? Yeah. Unrecognized instruction mnemonic. Just the two. Anyone get okay. Palm community. This must have answers. Come on. If this doesn't have, it's like we are done. So we code as follows: sat, go to R value, and try to assembly in a C code and compiling the R64 Linux crank. Instruction one set. And modify your question on basis what I think will be the answer. Extending assembly basis. Also the instruction you need to read out these answer. Okay. Nothing useful I guess over here. They just pointed about like SAT. Yeah, sure. New time. Now I can see R for R64. Let's take a look at all of these. Move mono, whatever. Okay. The only way I got to compile is by changing 64 to x86 64. Stop using the getting any information. Not sure this is the solution though. Okay. 64 is equal to yep. Wait, according to our solution, I removed mountage properties. Worked. Okay. Assembly voltage MCRP15. How is the current model service? Okay, with Raspberry Pi ARM weeks and architecture. I have now switched to this MCR. What there is system user access using MSR and MRS instruction. The R62. Okay. I think we guys I think we are done. Unrecognized instruction RDTSC in ARM assembly. I should just try this on like someone else's computer or stuff. I'm thinking, should I like compile this on like somewhere on a AWS EC2 instance or something? I don't think I can emulate this. So I have errors with Kimu, so I am not going to try that. Just the two of us. Man, I'm too tired. Okay. instantiated into assembly here. I think we I think we should break the challenge, no clanker challenge. I did try along for a lot of time, but I guess it's time. So yeah. Oh, yeah. Oh, wait, no, 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 wait, no, 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 wait. Yeah, I guess you guys saw it. I'm just going to stop the recording. Back again, continuing the video, and yeah, I just took a break for a small amount of time. I'm just too tired from this assembly code. Yeah, that's so. Oh, I shouldn't be giving it like the new code. Wait, why is it messed up again now? Okay. And this is the oldest one. So, yeah. I am on Mac M1 ARM architecture, and I think it is not able to recognize and map the registers or something. The RDTS instruction at the x86 won't work. Here's the ARM architecture equivalent for Apple Silicon. I feel so bad for using this. I'll just remove them. TB assert. ISO and later do not support first time error call to undeclared function TB assert ISO 99 later do not support implicit declaration. Call to undeclared function error TB assert. We'll call to undeclared TB assert qsort. What is TB assert? No, not a C. Wait, I didn't like review what the assembly code was. I'm just too tired. If defined R64, uncertainty 64 value, assembly volatile, MRS as we like. I'm not going to even understand this. RDTSC, else this, unsigned value, MRS 0. was the two first first time that which TV assert. Wait, so it needs TV assert somehow, but we don't have TV assert. Okay, so let's include past time, so we don't have TV assert. It is indeed asking for something. TV assert.h. Ha 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 ha. Implicit function declaration is equal to 0. Yeah, fine. What is it doing? Let's just fix this. Read POSIX-C source code to time so you can get control if not defined in debug. Okay. That was it. Wait, what is this doing? Wait, TB assert r is equal to 0, r is equal to percentage t, r. Okay. Wait. Letting customer session macro probability time base assert. Just true and is not prints another message. Time base conversion ratio on a pulse record counter frequency using always 1 nanosecond per tick, so you need to this for conversion. Okay. I don't want to understand this. Let's just get this over with. So we have compiled this. Where is the code here? So we do have this compiled. As you can see, nothing to be done. I just like it when the compilation works. Okay, so m driver and what was it supposed to be? Wait. So and then so our alert. Geometric mean 23.39 util 100 t put. Is that it? Wait, are there any spikes? no spikes. What is it doing there? Run the trace files to the trace directory. And run your heat checker. Useful in .py options. Just first. And WSC. Yeah. Let's try that. This must be like spiking somewhere. Yeah, error. MSBRK failed, ran out of memory. If we do this again. No, no big deal. Nothing. This is just standard, so it's not working because the implementation is not correct, I guess. So I guess, yeah, we have a working thing. We'll end the video right over here. I'm not that satisfied with what we have done like today, but okay, it's fine. Yeah, that's it. But anyway, I learned a lot of things. Like I learned about you can say like assembly, so about different registers and what's happening, about what was that, the tick counter, and EX R0, like the different registers, and that's great. But I think I should plan what I'm going to do like beforehand, so I don't waste time on like not so important things. But yeah, we have broken our no clanker challenge, so I'm not sure about that. I'm not like that happy about that. But anyway, like we tried everything. We tried for 1 hour, so it didn't like work out. So let's go. It's fine. I'm Aditya Bachorne, and I'm an engineer for fun. Bye.